Greeting everyone. We are still continuing with the series of trigonometry under proving some identities. So this is the question that was taken from November 2014 question paper for grade 12. So here we are given cos squared into 180 plus x plus tan into x minus 180 sine into 720 minus x cos x being equal to cos 2x. So here's the problem. I'm required to solve that left hand side is equal to a right hand side, and right hand side is cos 2x. So to recall is that cos 2x is a double entry. It can be written as 2 cos squared x minus 1 minus 2 sin squared x, or cos squared x minus sin squared x. So meaning if you can prove that a left hand side can be equal to any of the three, that will imply that the result is equivalent to cos 2x. Let us start. Solution. Okay, I'm going to work with the complex side and leave the easiest side. So I will prove my left hand side. So my left hand side is written to be cos squared into 180 degrees plus x plus tan into x minus 180 degrees sine 720 minus x cos x. Okay, so here cos squared into 180 plus x is something that you are not familiar with, so you are trying by all means to make something that you are unfamiliar with into something that you will be familiar with. How can we rewrite this? By saying cos into 180 degrees plus x, then you square it. So the two are equal, and then here it's plus tan. You have x minus 180. So having 80 as minus and x starting before 180 is something that you are not used to. So what are you going to do? You will add here 360. So here you have sine. You have 720. 720 is too broad, and you are not used to 720. You then go to your cast diagram. 720 is equivalent to 360. So meaning instead of 720, you can choose to rewrite 720 as something that you are used to. So you are trying to make something that you are unfamiliar with into something that will look familiar to you. So 720 is the same as 360 minus x cos x. All right, we are still continuing. Now we can work with cos at 180 plus. So we go to a cast diagram. This is what you should have in mind. On your cast diagram, 180 plus meaning it is on your third quadrant. It's 180 plus, 180 minus. So third quadrant, we are dealing with cos. And cos in a third quadrant, it is negative. It's only 10 that is positive on the third quadrant. So meaning here, you will have minus cos x. Don't forget about this squared. Plus, here you have tan. You have x plus 180. Meaning x plus 180, any of the two can start. Can be 180 plus x or x plus 180. Now it looks like something that we are familiar with. Sine in 360 minus, it is here on your fourth quadrant. It's only cos that is positive here, but sine is negative. Meaning here you will be with negative sine x times cos x. All right. So here, if you square this, you end up with this one. If you square -1, it becomes 1, so it becomes cos squared x plus. So here it's tan 180 plus 180 plus and time is positive on the third quadrant. So here, that means we'll end up with tan x. And then here, okay, we have minus sine x times cos x. All right. You work with this having in mind that you are dealing with what? We are dealing with a double angle of which is cos. So if you are working with a double angle which is cos on these results, there is nothing that involves tan. So meaning you can change tan and write tan as sine over cos. So here you continue with cos squared x plus you then change sine tan into being sine x over cos x times negative sine x times cos x. If you can look carefully here, this cos and this cos cancels. You are now left with cos squared x, and this negative will come this side, becomes minus sine x times sine x becomes sine squared x. This is what we have. Is there anything that we can do? It's nothing. You then go back to the double angle identities. You see here that cos squared x minus sine squared x, indeed it is equal to cos 2x. So now we know that this one is equal to cos 2x. Therefore, we managed to prove that left hand side is equal to right hand side. I hope you find it easy to solve such problems like this by trying to make sure that what is unfamiliar becomes familiar before you even tackle the equation or the question.